Rome built a watermill in southern Gaul that could feed a city, 16 wheels running in sequence down a hillside, grinding grain on an industrial scale in the 2nd century CE. The next time anything like it appeared in Europe, Rome had been gone for 1,000 years. That fact anchors a question that serious historians have debated, and popular history has largely answered already. The answer most people carry is this: Rome was close. Closer than any civilization before the 18th century. They had the engineering, they had the organization, they had the water, the concrete, the metallurgy, the logistics network, the centralized state. What they lacked was the idea, the conceptual leap from watermill to factory. One thought away, one insight from a different history entirely. That answer is reasonable. It is supported by real evidence, and it is wrong. Chapter 1. The watermill that fed a city. Sometime in the 2nd century CE, on a hillside outside Arles in southern Gaul, Roman engineers built something that should not have existed for another 1,000 years. The Barbegal mill complex ran 16 water wheels in 2 parallel rows, stepping down the slope in sequence, each wheel fed by the overflow of the one above it. The total output, by the best modern estimates, was enough milled grain to feed 12,500 people every day. That is not a farm. That is not a workshop. That is a food production facility operating at a scale that medieval Europe would not match until the 12th century at the earliest, and would not exceed until considerably later than that. When archaeologists first properly analysed Barbegal in the 20th century, the numbers were disorienting. 16 wheels, sequential cascade, centralised output. The vocabulary that kept appearing in the literature was industrial, and that vocabulary felt earned. Because Barbegal wasn't alone. Rome operated grain mills across the empire driven by water, wind, and animal power. They built aqueducts that maintained precise gradients across hundreds of miles, engineering tolerances that would challenge a modern surveying team working without instruments. They cast concrete that set underwater and has outlasted every structure built in Europe for the next millennium. The Pantheon's dome, unreinforced, still stands. The aqueduct at Segovia still stands. These are not the achievements of a civilization fumbling toward technology. These are the achievements of a civilization that had, by any reasonable measure, cracked the problem of large-scale physical production. So the question the title poses seems almost to answer itself. How close was Rome to an industrial revolution? Look at Barbegal. Look at what those 16 wheels were doing in 150 CE. The gap between that and a factory seems like a matter of concept, not capability. That assumption is worth sitting with, because it is not stupid. It is, in fact, exactly what the evidence appears to show. But Barbegal was built to solve one specific problem, and the civilization that built it never built another one. Chapter 2. The legend as a self-contained civilization. The Roman army was not an army in any sense that word normally carries. A standard legion on campaign comprised 4,800 soldiers. That number is the beginning of the description, not the end of it. Attached to those soldiers were 60 centurions, 300 artillerymen, 100 engineers and artificers, and 1,200 non-combatants, medics, surveyors, administrators, craftsmen. The legion didn't just fight. It diagnosed, it built, it calculated, and it fed itself. Every function a settled city required, the legion replicated on the march, and it marched far. The standard training requirement under Vegetius was 24 Roman miles in 5 summer hours, carrying 20.5 kilograms every day. That is not a military standard. That is a logistic standard, the minimum physical output required to move a self-contained production unit across a continent without breaking down. Vegetius records that marching was taught before weapons. Rome knew institutionally that a soldier who couldn't keep pace destroyed the formation. The formation was the point. Individual fighting skill came second. When the legion stopped for the night, it built a camp, ditch, palisade, gate, internal street grid, every night, on every campaign, in every province from Scotland to Mesopotamia. The engineering wasn't incidental to Roman military power. It was Roman military power. The road network that connected the empire wasn't built by a separate civil corps. It was built by the army as a byproduct of the army moving. What this adds up to is a picture of organisational precision that has no real parallel before the modern period. 500,000 soldiers supplied across 3 continents through a system of standardised equipment, standardised training, standardised camp design, and a professional officer class in the centurionate, capable of executing complex operations without waiting for orders from above. If you describe that system to an industrial historian without mentioning Rome, they would call it a managed supply chain. They would call it vertical integration. They would reach, instinctively, for the vocabulary of manufacturing. The legion was the most complex human organisation the ancient world produced. It coordinated inputs, standardised outputs, and scaled across geography with a consistency that the medieval world would not approach for centuries. The word that keeps suggesting itself is industrial. And the word is not wrong exactly, it is just pointing at the wrong thing. Chapter 3. The concrete, the dome, and the aqueduct. Roman concrete set underwater. That is not a metaphor for durability, it is a literal chemical property. Pozzolanic ash mixed with seawater produced a material that hardened in marine environments and continued strengthening for centuries after it was poured. Modern materials scientists have analysed Roman harbour concrete and found mineral structures that no contemporary synthetic process replicates. The Romans did not know why it worked. They knew that it did, and they used it everywhere. The Pantheon's dome spans 43 metres. It was cast in a single unreinforced pour sometime around 125 CE, and has not moved since. When Renaissance architects tried to understand how it stood, they couldn't fully account for it. When modern engineers analyse it, they find that the concrete mix changes composition from the base to the crown, denser aggregate at the bottom, lighter volcanic pumice near the top, in a graduated sequence that distributes load with a precision that looks, from the outside, like calculation. Whether that sequence was deliberate calculation or craft knowledge accumulated across generations of builders and never written down, the stonework does not say. The aqueduct at Segovia drops 11 metres across 15 kilometres. That gradient was sustained across valleys, through tunnels, over-arched spans of cut granite assembled without mortar, kept water moving at the correct velocity to prevent sediment build-up and avoid pipe fracture. The engineering tolerance required is measured in fractions of a degree. Roman surveyors achieved it using a device called a corributz, a wooden frame with a water channel and a plumb line. No lenses, no instruments, just levelled water and accumulated expertise. The Pantheon required no machine to cast it. The aqueduct required no machine to survey it. The harbour concrete required no machine to mix it. Every one of Rome's most technically astonishing accomplishments was the product of organised human knowledge, transmitted through practice, executed by trained hands working in coordinated sequence. That is the detail that the assumption quietly skips. Rome's technical mastery was real. The gap between that mastery and industrialization was real. But the gap was not conceptual in the way the assumption implies, not a missing idea waiting to be thought. It was structural. Rome solved every problem it faced the same way. More people, better organised, trained to a higher standard, moved and supplied with greater efficiency. The question is whether that describes a civilization approaching mechanical substitution or a civilization that had made mechanical substitution unnecessary. The evidence supports both readings. For now, Chapter 4, Marius's Mules and the Economics of Human Labour. When Gaius Marius needed to make his army faster, he didn't build better wagons. The baggage train that followed a Roman army on campaign was the weak point of the entire system. It was slow, it required guards, it created dependency, and in hostile terrain it became a liability that enemies could target. Marius's solution, sometime around 107 BCE, was to eliminate it. Not by engineering a lighter vehicle or a more efficient draft animal, by loading the equipment onto the soldiers themselves. Each man now carried his own weapons, his own tools, his own rations. The total load was approximately 40 kilograms. The marching standard did not drop. 24 Roman miles per day, 5 summer hours, every day of campaign. The soldiers who could meet that standard called themselves, with the particular dark humour of professional infantry, Marius's Mules. The nickname was not a complaint. It was an identity. Think about what that reform actually represents. Rome faced a complex logistical problem. How to move a large armed force quickly across difficult terrain without a vulnerable supply tail, and solved it by increasing the physical output demanded from each human body in the system. The solution was not mechanical, it was biological. Push the human harder, train the human better, select for the human who can sustain the load, and the logistics problem disappears. That pattern runs through Roman military and civil engineering with a consistency that is hard to see until you look for it, and then impossible to unsee. The aqueducts were surveyed by men with water levels and plumb lines. The roads were laid by soldiers. The camps were dug by the same men who would fight the next morning. Rome's answer to every problem of scale was the same answer: organize more people, train them to a higher standard, and extract more coordinated output from human effort. Barbegal looks like an exception to that pattern. 16 water wheels replacing the labour of hundreds of millstone operators. That looks like mechanical substitution, the thing Rome's critics say it never managed. But Barbegal served Arles, a specific city with a specific grain supply problem that the local human labour pool could not solve alone. It was a fix for a local constraint. The rest of the empire kept milling grain the way it always had. Marius didn't build better wagons because better wagons were not how Rome thought about problems. Rome thought about problems in terms of human bodies. How many? How trained? How loaded? How moved? The mule was the solution because the mule was always the solution. The civilization that produced Barbegal also produced the soldier carrying 40 kilograms across 30 kilometers of Roman road. Those two facts belong to the same system, and that system was moving toward perfecting human labor, not replacing it. Chapter 5. The Slave Supply and the Substitution. Rome never made. Every theory about why Rome didn't industrialize eventually arrives at the same answer: slaves. The argument is clean and convincing to a point. Slave labor was cheap. Mechanical labor requires capital investment, maintenance, and technical knowledge. If you can solve a production problem by purchasing a person and working them until they break, the economic incentive to build a machine that does the same job simply does not exist. Rome had slaves in the millions. The incentive never arrived. The argument holds. It just isn't sufficient. The slave supply did contract. The late Republic and early Empire ran on the output of military conquest. Every campaign produced prisoners, and prisoners became labor. But Rome's territorial expansion slowed in the 2nd century CE and stopped in the 3rd. The slave supply tightened. Prices rose. The economic conditions that the standard theory identifies as the prerequisite for mechanization, labor becoming expensive relative to capital, arrived, broadly, in the late imperial period. Rome did not mechanize. It hired barbarians instead. That substitution is where the argument breaks open. When human labor became harder to source from one population, Rome sourced it from another. The Federati, Gothic, Frankish, and Hunnic fighters recruited under their own commanders, fighting in their own styles, replaced the citizen legionary not with a machine but with a different category of person. The organizational response to a human labor shortage was more human labor, drawn from a wider and less controllable pool. There are two ways to read that failure. The first is the incentive argument. Slave prices never rose high enough, fast enough, to make mechanical investment rational before the political system collapsed. A few more centuries of stable empire, and someone would have made the leap. Rome was one supply shock away from a different history. The second reading is harder and less comfortable. Rome's institutions, the legion, the centurionate, the engineering corps, the agricultural estate, were not just using human labor. They were built around it at a level that made mechanical substitution not merely unattractive, but categorically outside the system's logic. The Roman engineer who designed Barbegal understood water as a force that could be redirected and multiplied. There is no evidence that any Roman thinker extended that understanding into a general principle, that mechanical force could replace human effort across production as a whole, not because the idea was unthinkable, because the entire institutional apparatus of Roman civilization was organized to make it unnecessary. The slave theory says Rome lacked incentive. The structural argument says Rome lacked the category. One claims a missing motivation. The other claims a missing frame of thought entirely. The evidence does not settle it. What the evidence does show is what happened when the labor supply finally irreversibly broke down. Rome did not industrialize. It collapsed. Chapter 6. The Recruitment Crisis and the Collapse of the Human Engine. By the late Empire, Romans were cutting off their own thumbs. The ancient sources record it without apparent surprise. men mutilating their sword hands to disqualify themselves from military conscription. The thumb that could grip a gladius, removed deliberately, permanently, to avoid service. In the early Republic, Roman citizens had brought their own weapons to war. Military service was a civic obligation so embedded in Roman identity that the word for a property-owning citizen and the word for a soldier were functionally the same category of person. By the 5th century, that identity had inverted so completely that men were performing irreversible self-surgery to escape it. That detail is not a footnote. It is a structural diagnosis. The Roman formation system, the triplex aces, the cohort, the testudo, the entire interlocking apparatus of coordinated heavy infantry, required specific inputs to function. It required men who had trained together for months before they ever held a weapon in formation. It required centurions who had spent careers learning to hold a unit together under conditions that would dissolve any improvised group. It required standardized equipment produced by state fabrici and distributed through a centralized supply system. And it required, underneath all of that, a civic culture that produced men willing to submit to the training in the first place. When that culture fractured, the system had no mechanical fallback. There was no technology waiting to substitute for the trained legionary. The choices Rome actually made reveal the architecture of the crisis clearly. Vexillations, detachments pulled from individual legions and deployed as independent fragments, replaced full legion deployments because full legions were increasingly impossible to field. The Federati filled the gaps left by citizens who wouldn't serve. Gothic cavalry, fighting under their own commanders in their own styles, replaced the disciplined infantry formations that had defined Roman military power for 5 centuries. None of those substitutions worked. The Federati were not legionaries. They did not build camps every night. They did not rotate exhausted men to the rear and push fresh men forward in the systematic cycling that the triplex aces was designed to execute. They fought, sometimes effectively, but the system they were plugging into was already hollowed out, and they were not designed to sustain it. The century between roughly 375 CE and 476 CE is the laboratory result of what happens when Rome's human labour engine runs short of inputs. The Western Empire did not mechanize. It did not find a technological substitute for the trained citizen soldier. It fragmented into Germanic kingdoms whose military power rested on personal loyalty, individual warrior prowess, and cavalry, everything the Roman system had been specifically engineered to defeat. Vegetius, writing in the late 4th or early 5th century, produced the only surviving comprehensive manual of Roman military doctrine. He was describing a system that Romans of his own time could no longer execute. He was reconstructing it from documents because the living chain of transmission, centurion to recruit, campaign to campaign, generation to generation, had already broken. The knowledge existed on paper. The institutional capacity to act on it did not. A civilization that was approaching industrialization would, under existential pressure, have accelerated toward mechanical substitution. Rome, under exactly that pressure, reached for more people. When the people ran out, it reached for different people. When those people proved insufficient, it stopped. The human engine didn't transition. It ran out of fuel. Chapter 7. What Barbegal was actually for Rome didn't build Barbegal because it was moving toward industrialization. The mill complex outside Arles was constructed to solve a specific, local, pressing problem. The city needed more grain processed than the available millstone operators could produce. Arles was a major administrative centre, a port, a hub of imperial logistics in southern Gaul. Its population made demands on the grain supply that manual milling could not meet at the required rate. The cascade of 16 wheels was not a prototype, it was a fix. The Roman engineers who designed it were not theorizing about mechanical substitution as a general principle. They were solving the Arles grain problem, and they solved it with the most powerful tool available, which happened to be water moving downhill. That distinction, between a local solution and a general principle, is the difference between a civilization that builds one remarkable mill and a civilization that industrializes. Britain didn't industrialize because someone built a clever loom. It industrialized because the social, institutional and economic conditions of the late 18th century produced a general drive to replace human labor with mechanical force across production as a whole, in textiles, in mining, in transport, in metallurgy, simultaneously and self-reinforcing. One invention licensed the next. Capital flowed toward mechanical substitution because mechanical substitution had become, institutionally, the preferred answer to production problems. Rome's preferred answer was never mechanical substitution. It was human coordination at greater scale and higher precision. Every time Rome faced a production problem, grain supply, road building, military logistics, hydraulic engineering, the solution was more people, better organized, trained more rigorously, moved more efficiently. Barbegal was the exception that the system produced when local human labor constraints made the standard answer temporarily insufficient. It was not the beginning of a new logic, it was the outer limit of the old one. Rome was not close to an industrial revolution. Rome was the most refined human labor engine the ancient world produced, and that refinement was what made industrialization structurally unreachable. A civilization does not industrialize by perfecting the system. Industrialization is designed to replace. Rome had optimized human coordination to a level that removed, institution by institution, the pressure that drives mechanical substitution. The legion was the wagon Rome never needed to improve. The centurionate was the machine Rome never needed to build. The slave and the foederatus and the mutilated conscript were all versions of the same answer to the same question, asked across 6 centuries. How do we get more output from human effort? The Industrial Revolution required a civilization that had run out of that answer. Rome never did. It just ran out of the humans instead. Chapter 8. The Engineer Who Left No School. We do not know who designed Barbegal. No name survives, no treatise, no technical drawing, no letter to a patron describing the cascade logic, no apprentice who carried the method forward. The most mechanically advanced installation in the ancient world was built by someone whose identity, whose training, and whose understanding of what they had made are completely lost. The archaeology gives us the wheel housings, the sluice channels, the gradient calculations implicit in the stonework. It does not give us the mind behind them. That absence is not unusual for Roman engineering. Most of what Rome built was institutional rather than individual, the product of a system, not a genius. The aqueducts don't have authors. The road network doesn't have a designer. Roman engineering was transmitted through the centurionate and the engineering corps, accumulated in practice and replicated through training, which is exactly why it was so consistent across such vast distances, and exactly why it stopped so completely when the institution stopped. But Barbegal is different. The cascade design, 16 wheels in deliberate sequence, each one extracting energy from water that the previous wheel had already used, is not standard Roman hydraulic practice. It is an application of a principle. The principle is that mechanical force can be staged, multiplied, and directed toward a production problem at a scale that exceeds what any number of human hands could achieve in the same space. Whoever designed that cascade understood something about mechanical leverage that the rest of Roman engineering never applied at scale. The reframe this script has built says that Rome was structurally incapable of generalizing that understanding, that the institutional logic of human coordination was so deeply embedded that mechanical substitution as a general principle had no purchase. That reframe is supported by everything Rome did before Barbegal and everything Rome failed to do after it. The mill was used and then abandoned, and the method was not extended, and the empire that built it collapsed without producing a second one anywhere in its territory at comparable scale. But the designer of Barbegal knew, whatever they understood about water and wheels and sequential mechanical amplification, they understood it, they applied it, they built something that worked for generations and fed a city, and then disappeared from the historical record as completely as if it had never existed. The reframe accounts for the system. It does not account for that person. What did they think they were building?